Hi viewers, welcome back to the lecture video. In the previous session, we have seen the definitions for sheet metal work, sheet metal operations, and from this video, from this slide, we are going to see the various operations involved in the sheet metal works. You can see a number of operations that can be performed in a given sheet metal, and it ranges from bending, shearing, blanking, punching up to deep drawing, stretch forming, roll forming, and so on. So I have already said that we have a number of sheet metal operations, but put together it can be broadly classified into two types. It can be either a shearing process or it can be a forming process. In the shearing process, the sheet metal is cut to a desired shape, whereas for the uh, forming process, the given sheet material is bent to a required shape. So that is the basic difference between the shearing and the bending operations, forming operations, and the various classifications of sheet metal operations are listed in this slide. So we need to be familiar with the working principle of each and every sheet metal operation, starting from the bending to the roll forming. That will be discussed in the subsequent slides. So the process number one with respect to the forming operation in the sheet metal work is the bending operation, which is given in the slide. So bending is one of the process of sheet metal operations that belongs to the forming process, in which a force is applied to a piece of sheet metal, causing it to bend at an angle and form the desired shape. You can see the sheet metal in the given slide, in which it is a flat material which resembles like a straight plane this manner, and for our conditions for the given applications we require the sheet metal to be bent to a certain angle. So the angle required for bending, say for example the angle here is approximately 90 degree, so the 90-degree angle is bent here, so that angle can be called as the bent angle. And even after bending you cannot get the exact angle, um, 90 degree, so you get some kind of angle that gets reduced due to the physical property of the material. So that small angle is taken as the bevel angle. For instance, if you are planning for bending the sheet metal for 90 degree, and even if you are getting the dies and the punches and ram with respect to the 90-degree bending, after bending, due to its elasticity nature, the bending will not occur to the 100 percentage of 90 degree. So it gets some deviations, say for example 89 or 88.5 degree only after the process over. So the difference between the bend angle and the desired angle, that is called as the bevel angle. So that is represented here, which can be called as a bend angle or bevel angle. So there is going to be a plane which is neutral to the entire thickness, which is called as the neutral axis, and the total thickness of the sheet metal, it lies from 0.006 inches to 6.35 mm, that is 0.25 inches. So that material is taken as the sheet metal. So the range lies between these two values here. And before the starting of the bending operation, that is the starting line, that area is called as the flange length. And even after the bending, if the line is stretched to a horizontal line this way, and when the distance is measured from the unbent edge to the bent edge, that is the imaginary line, it can be called as a mold line distance. And mold line distance is the combination of flange length and the setback. When you add together setback and flange length, you get the mold line distance. And setback is going to be measured between the bent plane and the line at which the bending starts. So the line where the bending starts can be called as the bent line, and the imaginary line drawn between the two planes, horizontal plane and the vertical plane, can be called as the mold line, and the allowance set for the bent sheet metal can be called as the bend allowance. So this is measured here, and due to the elastic nature of the component, the total length of the entire workpiece sheet metal is not at all equal to the total length of the material after bending. So due to the elasticity, some amount of thickness is sacrificed, so the length is increased after the operation. So that allowance can be taken, measured from the two lines of flange length, that is bent line, which can be called as the bent allowance, and the total length utilized for bending is taken as the bent length here. Since the total length of the material is bent here, so this length can be called as the bent length. So these are the few characteristic features of the bending operations. You can see the machine which is called as the press brake machine, which is used for making the operations performed over the given sheet metal. So we have the major components such as bed, and the component that is used in the operations is the sheet metal, which has to be taken to the applications, and there is going to be a back gauge, and you have to apply the pressure over the sheet metal for the operations to be performed, which is called as the ram. If the ram is guided by the hydraulic power, the ram can be called as the hydraulic ram. And the ram, it has the punch at its end, and the punch is going to be the component that is used for applying the force over the sheet metal, and die is going to be the material which is at the bottom side of the entire system, upon which the sheet metal is placed. And during the operation, since the components, few components are in dynamic condition, that is in the moving condition, it creates a tremendous amount of vibration which is carried to the ground through the bed, and the bed is capable of carrying all the vibrations, and the bed material is made up of cast iron, which is capable of taking all the vibration loads. So this is going to be the definition for the entire components in the given system.